Thank you to our sponsors for supporting this episode of Troxel, BQE Core, and Avail. We'll share more about them later on in the episode. Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have conversations with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. In this episode, I talk with Dr. Wassim Jabi. Wassim is currently a professor at the Welsh School of Architecture, Cardiff University, where he leads the digital design area and is the chair of computational methods in architecture. Dr. Jabi has published widely on topics ranging from parametric and generative design to the role of light in architecture and building performance simulation. He is a member of the editorial board of the International Journal of Architectural Computing. He earned his Bachelor of Architecture from the American University of Beirut and his Master's and PhD in Architecture from the University of Michigan. His research interests and expertise are at the intersection of parametric design, the representation of space, building performance simulation, and robotic fabrication in architecture. That, my friends, is quite a quiver. In 2013, Professor Jabi authored the book Parametric Design for Architecture and has secured several grants over the years to investigate innovative digital fabrication processes of architectural components and structures, and to develop a conceptual framework and schema for the hierarchical and cellular spatial representation of buildings throughout a concept called non-manifold topology and a set of algorithms and tools that test the potential of this approach for use cases including energy analysis, structural analysis, spatial reasoning, and fabrication planning. That is Topologic, which is his latest project, and we get into that in this episode. We also discuss how Topologic grew out of a need to build lightweight models that are adept at representing space rather than merely components and assemblies of manufactured parts, the notion of a spatial vocabulary and creating a dictionary of dictionaries in architectural design software, why the concepts in Topologic have incredible utility for practitioners today, the value of Topologic and the library being open sourced, how it works and what the existing platforms that it works within are, including the excitement around other open source software, including FreeCAD, Blender, and BlenderBIM, making the case for why there's no risk in using open source software, why the Topologic team is rethinking the BIM process by going from simplicity to complexity rather than how other platforms, like Revit, force one to make something complex up front, which in turn makes it enormously more difficult to change things later. And we all know that things change later. Giving the design team the ability to ask the model questions and get meaningful answers rather than just quantities or the typical 2D representational output, for example. The idea of material passports and the blockchain. How digital twins fit into this from an owner's point of view. Where things might be headed in the future with this groundwork that's been laid. And so much more, if you can believe it. This was a fantastic conversation with Wassim, and I hope you'll not only find value in it for yourself, but that you'll help add value to the profession by sharing it with your network. It's literally the smallest act of generosity you can do to support this show and to help broaden the reach of conversations like these in my attempt to elevate the industry with your help. I would also appreciate you visiting the sponsors who help make this episode possible. So, without further ado, I bring you my conversation with Wassim Jabi. Wassim, welcome to the podcast. Great to see you, and I'm glad we could make this happen.
Great. Thank you for having me.
Yeah, I'm excited about the work that you're doing. I think I understand what you're doing. And the reason why I think I understand it is because I come from a background of non-architectural specific modeling programs.
Okay.
So because of that, when I was building models, and as we say back in the day, we didn't have walls, we didn't have floors, we didn't have ceilings. It was just raw geometry, and it was representative. And so I would love to hear how you got to where you are now with Topologic and why it's important to you. So kick us off and take us back. And how did you get here, Wassim?
Right. The story goes back quite a while, so I hope your audience has the time to listen to it. But it really started from the days that I was at Michigan, at the University of Michigan in Ann Arbor. I did my master's there and I did my PhD there. And I joined a group of 2 professors and a postdoc, Harold Borken, Jim Turner, and Ted Hall, that were one of the early pioneers, kind of like unsung heroes of what, CAD and 3D modeling. And they were really focusing on 3D modeling. And their concern was how to represent 3-dimensional geometry, quote unquote, the correct way, the right way. And they were having these big discussions. And I was just a student, just listening into these discussions that they're having about what kind of representation, what kind of data structures are appropriate for what they want to do, for what they want to represent. And that kind of instilled in me this need to look at not just kind of like solving a design problem computationally, but making sure that the infrastructure and the data representations that you're using are appropriate for what you want to do. And not just be satisfied with whatever engine you're using gives you. And at the same time, they were talking about the fact that, before you design a very complex building, and because of the hardware limitations they had at the time, we're talking early 90s here, they wanted to find very efficient ways of representing things that are not computationally expensive. And then again, that instilled in me the need to create as lightweight representations as possible.
Was this before even OpenGL at that point? I believe. In other words, we weren't working in shaded models at that point. We were always working in wireframe. Yeah.
Yeah. I mean, just to kind of give you an idea, we were doing our own cosine and Gouraud shading. I mean, we were writing our own algorithms for that. My contribution in my master's was to introduce a module to the software. It was called gedit, that casts shadows, and I did the casting of the shadows not through like the video card like they do it now. No, I mean, I actually did Boolean operations. I mean, transformations and project the surface and cut the surface. Yeah, exactly, projected. And of course, well, it was very, very slow. But the nice thing about it is that it gave you surfaces that are analytical. You can calculate the area of your shadow and sunlit areas. So that information was available. So, let's move forward now to the time that, about 2013, perhaps 2014, I forget the exact year. When I was at the Wells School of Architecture at Cardiff University, I started getting interested in linking early design to energy analysis, because I wanted designers and architects to understand the consequences of what they're doing in terms of energy performance, before BIM, before getting into the complexity of BIM. So I started building software that would link to OpenStudio and Energy Plus and all of that. And at the same time, I'm hearing about what Professor Robert Aish was doing. He was at Bentley working on JRF components and then went to Autodesk. And he started talking about design script, which is this language that he actually first included in AutoCAD. So I went to a workshop, I think in Cambridge and then in London, where he was presenting it. And then at the end of that presentation, he says, oh, by the way, there is something in design script and the engine that it uses that uses something called non-manifold topology. And non-manifold topology, he said, is very compatible with energy analysis. And the moment he said energy analysis, obviously my ears perked up, and I said, okay, I need to understand what this non-manifold topology is about. And it turns out to be a mathematical representation where, just to put it very simply, rather than just having a solid that has nothing inside of it, you can subdivide that solid and have surfaces inside that solid. You can actually do a lot more. You can even mix in edges and vertices that are hovering in the middle of the space. So it does not have the limitations of a classic solid modeling representation, where everything is just a simple polyhedral solid.
So we could think of this analogously like a palette with a bunch of bricks on it that's been shrink wrapped with saran wrap, to hold it all together as it goes on the back of a truck and goes flying down the freeway. That is the non-manifold topology, meaning it's like a shrink wrapped envelope full of stuff.
Yes, exactly. You can have things inside of it. You can subdivide it into cells. So that shrink wrap that you're talking about, that you're describing, is what we call a cell complex. Imagine a complex of buildings. Just replace the word buildings with cells. It becomes a complex of cells. And these cells that are inside a cell complex are guaranteed to share a face, at least one face. And that gives you a lot of abilities to do analysis on it.
So they're contiguous in some manner, and that configuration could have multitudes of configurations, right? But you're looking at one configuration, and they have to be contiguous in some way because they share a face.
Exactly, like soap bubbles. Exactly. It turns out that this is actually great for energy analysis, because energy engines like Energy Plus and OpenStudio that uses Energy Plus, they depend on topology, how things are connected, more than even geometry. I mean, they need to know basically what rooms are connected to what room through what surfaces, and that's the surfaces are what's kind of transferring the energy from one space to the other, and they need to know the area of that surface more than the exact shape of it, actually. But obviously, it helps to have the exact geometry. So I took at what he is talking about in that design script, and as I said, it was in AutoCAD, and I went and ported my software to use that capability and build models using non-manifold topology and connected them to OpenStudio, and then brought the analysis back and displayed them using color coding. And it was very, very successful, and we published on it. And we were really excited about it. I showed it to Robert H. We became friends. He wrote he wrote a part of my book. At the end of the book, I was publishing a book called Parametric Design for Architecture, and he wrote a chapter on design script there. What was happening at the time is that he was actually in the process of leaving Autodesk, and Autodesk was in the process of taking design script and making it the language of Dynamo. And in the process of doing that, unfortunately, they took away the non-manifold topology features of design script. They took them out, they did not enable them. They disabled them, basically.
They didn't include them. Okay. And
that's where I had discussions with them. I said, please bring it back. It's my research, etc. And they couldn't. They couldn't because of licensing, because of technical issues, and also because they honestly told me they don't see the market kind of value of it. They just did not see a demand for it because they thought it was a very esoteric topic. So I went to Robert H. At that time, he had become a visiting professor at UCL, at the Bartlett in London. And I told him, hey, these guys are really nice guys, that are doing Dynamo, but they can't do it. They cannot bring it back. So how about you and I write a research proposal, get money, and write software that is open source and available. That's where,
You're doing an end run on Autodesk here. I get it.
Yes. I mean, it's heartbreaking because, as I said, this was available in 2013. And the engine, obviously, I say ASM engine goes way back before that. This whole area of non-manifold topology, if you actually do your research, goes back to the 80s and the early 90s. It's all available. I kept telling Robert H., we're archaeologists, we're not researchers. We're really digging up all this old research and re-implementing it. Now that we have the power, we have modern systems, we have Dynamo and Grasshopper and spatial, we can do a lot more with it. But it kind of came back to it.
My personal experience with that is with the Axis engine that FormZ was using, and everything was about the components that you're talking about, the vertices, the edges, the surfaces, the solids. They were famous for being a solid modeling application with true Boolean operations and all these things. But I think that's why I understand the language that you're saying, is because I came through that time, which I think FormZ was started in the late 80s, early 90s, which used the Axis kernel for its modeling engine. Yeah,
absolutely. When we started looking at engines, and these engines, as you know, they've been around for a long, long time. They're very old, as you said, from the late 80s. Some of them even from the 70s. They were written in Fortran and then upgraded. But we found that they are split into two classes. They're either manifold, meaning they do just solids, or they are non-manifold, and they can handle this internal subdivision. So we settled on a very powerful non-manifold engine called Open Cascade. It is open source and free. And lo and behold, it was also the engine that is under IFC OpenShell. It's under FreeCAD. You find Open Cascade popping up in different areas. And it is quite complex to use. So our mission was to write an API on top of it, that is Topologic, that it rationalizes and simplifies the access to its capabilities. So we followed the classes that they have all the way from like a vertex to an edge to a face, a wire, cell complex. All of these things we have represented, and we wrote methods that access these and combine them in a very rational, very simple way. And most of the time we spent in the research project were arguing and discussing over a table, what should we name these methods? What should they do? What should include in the core? What should not be included in the core? Because we wanted to, as I said, to do it right and to do it elegantly. And I've heard, not to, pat myself on the back, I've heard a lot of comments about Topologic being a very elegant API in the sense that, everything seems to be logical. And I think it takes, I really think it takes designers and architects kind of to do these things, because we were like looking at the aesthetics of it, like the naming and how what kind of methods are named and what values they return and all of that.
It's interesting to think about that vocabulary that you're speaking about. And I as I'm like looking at your website and reading through the classes and all of the different pieces that make up these different assemblies and thinking about it as a hierarchy, it's interesting now to think about the approach to BIM and 3D modeling, where I think architects, more than any other kind of 3D modeling that happens, especially in BIM, is we're thinking in terms of assemblies and not individual components. And I think that gets away from, that's why it's hard for people to see the kinds of things that you're talking about, because what you're talking about is like an underlying framework of space. What defines space? And I think for architects, they think about elements that occupy space. When we look at a room in Revit, let's just say, they don't think of it as space. They think of it all the things that enclose space. And I think what's different about what you're doing is you're actually able to interrogate space itself within these cell complexes.
That's exactly right. Even the title of the proposal we gave to the living room was called Enhancing the Representation of Space in Building Information Modeling. Because we looked at BIM, and exactly as you said, they focus on doing the stuff, the components, the physical components. I actually went through when I was doing the proposal, I on purpose went through the beginner's tutorial for Revit, went back and said, okay, if I am a beginner what they tell you is, do your foundation, put a slab, put walls.
Build it like a building.
So you are building it like a kit of parts, obviously. And they don't talk about space. They don't talk about the kinds of strategies that architects do at the beginning to configure space and how it is connected and how it is composed. And then you I call it thickening. You thicken those spaces into their components.
Like that term. That's thickening. I'm writing that down.
I'm gonna copyright it for sure.
Yeah, trademark.
Trademark it, yes.
Dr. Wassim Jabi. So, do you feel like when it comes to, documenting architecture is one thing, creating architecture, designing, conceptualizing architecture is very different, and I think it is very much more of a spatial exercise early on, and so maybe we're talking about the step before Revit more than anything. Do you see it like that? And then maybe it has a life that continues on through the documentation process with the tools that you've made? Or do you see it being in like the inception of it is during that documentation phase? It seems to me it's earlier.
Yeah, definitely. No, you're absolutely right in that. We think of Topologic as a rethinking of the BIM process, so that because I'll tell you, I'll step back. I'll tell you just kind of the stories that I get or the requests that I get. Once we have announced Topologic, many architects came back to us and said, oh, we have all these BIM models and we want to do energy analysis on them. Could you please convert them back to Topologic? Because Topologic is great at doing energy analysis.
And I'm laughing because this is the process that almost every architect goes through, because they've built their whole model and then they need to analyze it, and then they need to dumb it down so that the analysis software can do its work on it. And we've been through that process over and over again. So if that stuff was there the whole time and I could just reveal it, because it doesn't need to, I don't need to see it all the time, right? But if I could just reveal it because it was always there, oh my gosh. And to me, like, we're skipping to the end, but like the so what, who cares about this is, if this was there, it would save you tons and tons of time in the end, because you have to justify the design for various reasons with various outcomes in that process.
Yeah, absolutely. I believe, honestly, that the main contribution of Topologic would be, if it's ever successful and prevalent, is that it will change the design process. Not that it will bring new technologies, not that it is faster, not that it's more robust than any piece of software, that it will actually convince people to change their mind and say, before complexity sets in, and it is too late in the game to actually analyze your building. And we're not just talking about energy analysis. There's a lot of analysis that you can do about shortest distance, about fire egress, even quantity takeoffs that you can do on what I call concise models that are semantically rich. They're laden with information, but they are very, very lightweight in how they are represented before you go ahead and deal with all that complexity. So just going back to the story, I would tell them, guys, I'm sorry, I'm not a magician and Topologic is not magic. You will always be in trouble trying to get something complex and simplify it. It's much better. And I firmly believe this. Software should be the agent that actually populates these strategic, concise models with BIM components. We as humans and designers should not be spending our time putting chairs in a conference room and placing windows on a facade. I think we should set the rules for it once and for all and do a shape grammar, do a kind of a language for the firm, for whatever you want. Say, this is our language, this is what how we do architecture. Put our effort and time into conceptual models, and then just give them to software to actually thicken them and populate them and to convert them into BIM models. And we have proven it. We have done that.
You called it shape grammar? Is that what you said?
Oh, well, yeah. Shape grammar is basically, it's just a field from the mid-70s with Steiny. It's basically rules, shape rules and shape vocabulary. As architects, we all, as architectural firms, like whether it's Zaha Hadid, whether it's Foster, whether it's whatever, they have a certain architectural language. And that language is basically a set of rules and vocabularies that they use and reuse. So you might as well formalize that, document it, and then deploy it as a system that converts these conceptual models to BIM models. And then it will be always consistent and always accurate.
I like that. That makes a lot of sense. Because coming from a design background and working early in the design process with lots and lots of stakeholders on a project, we want to work as simply as possible. That could be analog. We want to use foam core cutout squares and rearrange them on the table when we're thinking about adjacencies, things like that. We could cut them out of solid, like acrylic. We've done that as well. Colored acrylic blocks that represent space, and we move them around with the different stakeholders at the table, so they're a part of making those decisions. But then we translate that in, or maybe we start digitally. And there's a lot of firms out there who have a spreadsheet that automatically builds boxes inside of Rhino, for instance. We've done that as well. And they're color-coded and they're labeled and they've got a certain size and spatial attribute to them. And I think what the things that you're talking about do make the most sense, to have those representations of space as the most lightweight version that could possibly be geometry-wise, so that we can play during that process. And we don't have all of the rules of what's this going to be made out of and what color is it going to be and how's it going to feel yet. I mean, those are all kinds of we're talking about the earliest stages of design and the lightweight representation of that. And then, as you said, you can attach as much or as little to those things as you want, because they can be very rich in their data, but representationally, they're very lightweight.
100%. That's exactly right. The nice thing about it also is that you are not just simply placing these blocks. I mean, I think your metaphor of play and blocks is exactly right. That's how we see Topologic. It's not there yet in terms of interfaces, but we have the infrastructure for it. But once you are placing these blocks, they are also spatially aware. They're not just dumb blocks, being placed in a display scene. They actually know what is next to them. And therefore, that gives you the ability at any point to say, okay, let's do some analysis on it. With one click, you can just simply get some kind of information back about what you are doing.
That's really interesting, because there's so many times later in the process, even after the project is built, where architects would benefit from knowing per project type or per client or per region or whatever they wanted, like how did we place, in what adjacencies did these things actually end up? Because then you could inform the future design process shortcuts that could come out of that. Well, 80% of the time, we're laying out a school administration building, we've done it like this. And to have that spatial awareness that you're talking about encoded in the geometry, so that we could pull out that amount of information at some later date when we actually care, because we're going to do it again, it makes so much sense, and we never do it, right? Like, we don't have that information. It's not that we don't want it. We definitely want it, but we don't have the ability to pull that out without going in manually and looking at that kind of thing.
So you mentioned something really important here, which is, getting information out of the stuff that you've done in the past. And to us, we've taken this. We've said, okay, if we are doing adjacencies, etc., basically what you are building behind the scenes is a network of edges and vertices that are connected. Imagine one room has one vertex, adjacent rooms have an edge between them. What you end up with is a graph. A graph is just simply another word for a network of edges. Now, so what we have done in Topologic is that we said, okay, then rather than keep that graph as something informal, we might as well convert our cell complexes and the geometry that we're getting into formal graphs. So we actually have now graph data structures. And every node in that graph has the full information of the space that it represents. And every edge has the full information of perhaps the surface that they share, because that's a relationship, or through the door. You go from the room to the door to the corridor. So we build those graphs, and you can imagine that if we have those graphs saved, and we have now created hundreds and hundreds of these buildings, as you said, and we have patterns. We have things called graph databases where we can save these things and then we can mine information. And we have something called graph machine learning, where we can use all this, previous data to learn to recognize new graphs. So if you're designing a new building, it starts building that graph. Maybe it's a partial graph. Maybe some nodes are not yet defined, but that's okay. It can deal with missing information. And your AI will look at your previous work and says, it looks like you are designing a wing of an administration building. And here is some examples of your best practice that you've rated highly. It becomes a recommender system, very much like what you do on Amazon.
Yeah, it's a recommendation engine, or it's autocomplete suggestions, things like that. Again, just to go back to this idea of like laying out an administration building, you've got a certain program that is usually hard coded, right? That it's something the client asks for. We need all of these spaces, but you've also done 15 or 20 other administration buildings, and those two different lists of items may not be exactly the same. And that might just be something that the computer could just say, hey, you're missing this thing that we've done 15 other times. Do you want to include it here as well? And I can't tell you how many times that I've laid out spaces like that, where it's like a cell complex to your vocabulary here, and have left out one space because you're translating it from a piece of paper that somebody gave you, or an email that somebody gave you, or it was brought up during a session in a meeting and it was in a meeting minutes document somewhere. And you can, like, there's all these various inputs into this system. And if you're not extremely diligent about capturing, and which architects are extremely diligent about capturing all those, because we're in service to the client and we have to do a building that respects the building code and it has to perform to all of their needs. But at the same time, you don't know what you're forgetting. So it seems like this idea of a recommendation engine, like this idea keeps coming up, is when Microsoft Word had Clippy back in the day, right? It looks like you're writing a business letter. And we've talked about Clippy for architecture in several episodes of this podcast. I mean, that's basically what we're talking about here. And I could see that just being a huge, I don't know, it's like a lot of times you forget that one little thing and it breaks the whole puzzle that you think you've already solved, because now you have to shoehorn a mechanical room in when you'd never planned for it ahead of time. And the amount of time that it takes then to go back and rework all of that, especially if you're later on in the project, it's only harder and harder, right? Because you've hard-coded so many layers of things on top of that lightweight space representation that I could see the benefit of using a system like this being enormous, especially if you get to analyze the previous work that you've done and potentially even other architects who work in the same space. If it's healthcare design, which is an extremely complex adjacency and rules and circulation paths and lengths of paths and all those things, you could imagine that everything could kind of level up a lot more quickly together with a system like this.
Yeah, I've been getting queries from people who are exactly doing hospital design. They call it functional hospital design, I think. And they're asking me, I mean, basically they have very severe problems where, as you said, just the complexity of it and keeping track of it. They just wanted a system that will be able to answer spatial queries very easily, to say, okay, what are the two rooms on each side of this wall? Because that will determine what that wall material is going to be, whether we can put some pipes in it or not, or do we need to line it with lead because it's an X-ray room, or whatever it is. They just need to know, here's room A, room B, and the space and the surface between them, and what is that information? And to me, it still boggles my mind that in Revit, and all kudos to Revit. Obviously, it's a behemoth and very well received and well used. But even to this point, I cannot take a room and say, what room is above me or what room is below me? Just say, do I have a library below me and I'm a dance floor? And am I going to be bothering the people below me? And, or can I puncture the surface to go from one side to the other? Or something as simple as, okay, I have a staircase and I have a side wall to it. I move that wall and the staircase just stays where it is and creates a gap. And why isn't that connectivity kind of built in? Sometimes it is built in and sometimes it's not. And we just think, no, that's not the way to do it. If it needs to be built in, that connectivity, it always needs to be there.
Let's take a quick break to share more about our sponsors. In this podcast, I talk a lot about all the realities with my guests. Mixed reality, augmented reality, virtual reality, all the realities. And I've got a new message for you from my friends at Avail. Let's talk about the new reality, which is that content, as I've talked about in the previous message from them, both wants and needs to live everywhere. Long gone are the days of saving files to your local hard drive or to a single on-premises server. In order to solve remote collaboration, information has moved to the edge. The cloud is king. And the number of cloud services out there dictate that the number of storage locations will continue to grow dramatically. Where do you store your files? BIM 360, OneDrive, SharePoint, Box, Dropbox, AWS, Azure. Chances are you probably save them in some weird combination of those that I just mentioned, and more. Well, here's the point of this message. Avail hides the complexity of where content and information resides. What file to use used to be your biggest concern. Now it's where do all those files live. Avail takes where out of the equation, which means that with Avail you can actually find your mission critical and not so critical files too, right when you need them. Avail helps get you the information you need faster. Go to getavail.com today to learn more. Systems and standard operating procedures. You already know that's how to build a profitable business and find the freedom you want. You need systems and procedures. But you struggle with choosing the systems you need most and how to implement those systems quickly so you can get back to doing what you love most. The Designing Your Business Masterclass series was created by an acclaimed architect and business consultant, Douglas Teager, FAIA, to help fellow architects and engineers run their firms more profitably while maintaining a healthy work-life balance. Douglas grew from a solo practitioner to become managing partner of his 30-plus person firm, and then later sold his firm so he can do what he does today, helping architects be more successful at Teager Consulting. On the third Wednesday of every month, Douglas dives deep into an essential topic that will strengthen the profitability of your firm and make it sustainable for growth in the years to come. Register now for the Designing Your Business Masterclass with Douglas Teager at bqe.com/masterclass and start implementing powerful systems for the profitability you need and the freedom you want. Every live masterclass session includes AIA continuing education credit, and when you visit bqe.com/masterclass, you'll have access to the full library of past sessions on demand. The Designing Your Business Masterclass is free, and it's brought to you by our friends at BQE, the makers of BQE Core, the software that makes it easy to manage your projects and people for maximum productivity and ultimate profitability. Register now for the next Designing Your Business Masterclass at bqe.com/masterclass. That's bqe.com/masterclass. And now let's get back to our conversation. So is there a way to extend this library that you have? I assume the answer is yes, but I want to hear your thoughts on this, which is the purpose of the extension would be to assign rules like you're talking about, where acoustic separation, fire separation, certain things that can and cannot happen inside those wall cavities, wall thickness and cavity thickness between spaces that are necessary. If it's a plumbing room that, that's a line of toilets down the wall, you've got to have a certain amount of space. It seems like all of those kinds of rules could then be encoded on top of the types of spaces that they are and the requirements that those spaces might have. Even materials, all of the things that you're talking about here could just be encoded in and be done automatically by laying out space.
Yes, exactly. I mean, that's the vision. That's what we hope will happen, with Topologic and linking Topologic to BIM systems. That's the missing piece. I have seen examples of it where it is done on a case-by-case basis. So, I'm working with an architect who works for a large German architectural firm, and he has done exactly that. He has taken the rules that his firm uses for how to configure a BIM model in Revit, and takes a topologic model, applies all these rules to it, and just in one click, that topologic model becomes a BIM model, and quite a well-resolved BIM model. We're not talking about really bad geometry. I mean, it's a BIM model that lives up to their standards, and then from there on, they detail it and they take it on to construction. Now, Topologic actually has been used in that process on a 20 million euro student housing project in Germany that's under construction. So it has kind of proven itself that process, if you start with a strategic conceptual model and apply your rules, as you said, you can go from conception to construction, very, very easily and very consistently.
Does the model that you're producing then have a life beyond construction? I could imagine a lightweight model being very useful for an owner later on, where they don't need to have a copy of Revit, for instance, among any other piece of software like that. But I could imagine it being useful beyond construction.
Oh, yeah, absolutely. Some people have talked to me about it. We are waiting for people to use Topologic in different use case scenarios. And one of them is facility management and digital twins, and making sure that, you can use a very lightweight model that is interconnected and use it to manage your building. I know that another colleague of ours that was working in the same area, I think they used it on a tower, I want to say in Dubai or Abu Dhabi, where they can do fire simulation. So if the fire kind of breaks out in one room, they can kind of find out the egress that people are supposed to take in order to avoid that, the safest egress. And you can imagine that you can use that in a building management system. God forbid, if a fire breaks out, you can start informing people about or automatically close doors and open doors and lead people safely down the correct staircases.
It seems also like I know I'm skipping around in like the grand timeline of design and occupancy of a building, but when you're in those earlier planning stages as well, when you're thinking about fire egress, to your example, it would automatically be able to tell you if the route has all of the right designations, signage wise, where they need to be, and if it's contiguous. Like thinking about the surfaces that have the fire rating through just basic pattern recognition, you would be able to easily tell through that representation whether the route is fully has the full fire rating that it needs to have to justify it to the code authority, but also to build it correctly, right? I can just see so many uses for that simple pattern recognition representational way of looking at the information that's encoded into these pieces so that we know we're doing it right.
Yep. And you mentioned an important word that is near and dear to me and to a colleague of mine named Miguel, information. In the sense that what you are describing is really just simply information access. You don't need very heavy geometry to get that information out. You just need the connectivity and you need the information to be embedded in the right way. So you can get a lot of questions answered by the kind of representations that Topologic is doing, which is how things are connected to each other and information embedded in a hierarchy where I can not just simply put information, let's imagine you have a cube. It's not like the cube will have just simply a dictionary and attributes. The faces will have different dictionaries of that cube. The edges will have different dictionaries. Even the vertices will have a different dictionaries. So there could be hundreds of dictionaries embedded, and also, of course, other geometries embedded in that. So it can have a content system. And those geometries can have dictionaries. So you can have a hierarchy of information. So we decided that the complexity, or at least the rigor, could be the rigor of information rather than a huge complexity of geometry.
Writing down that the rigor of information is really important. And I'm thinking about it also from later on down the road when an owner, going back to the, again, kind of flipping around the timeline of projects here, when an owner has an occupied building and at some point they decide they're going to remodel and they're going to change the use of a space to something else, it seems like a very simple task having this type of information at their fingertips to say, well, what's it going to take to do that? Because if you change the type of room from, let's say it was a machine shop and now it's going to become a dance hall, you can, by changing the use, there would be attributes assigned to that kind of a use, and it would be very easy then to just understand from a very high level what it's actually going to take to do that. Because now you're talking about different acoustic separations, different materials, different air quality regulate. I could just see so many different things. And it's like, if by tying that to dollars, today's dollars, we can get a very good idea very quickly of what it would take to do that without having to go through the design process, right? It's just a very simple kind of reassignment at that point to understand that type of thing.
Yeah, we can take it even further. My colleague Theo Dunas, who's a professor in Robert Golding University, he and I collaborate on blockchain technologies and all of that. But mainly, what we are aiming to get to finally is circular economy. And for that, you need material passports. So these dictionaries that I talk about them as dictionaries and information, he uses the term material passport because when you have a digital twin that has material passports assigned to all the components, down to the very last component, then you can very easily do analysis on what it would take to disassemble that space, reassemble it, recycle it, reuse it in different ways. And when you take these material passports and you put them on a blockchain, then they are immutable and they are verifiable and they are traceable. So you can find out who the manufacturer is, call them up and say, you've put this thing 20 years ago and it has these types of, characteristics, and you can disassemble it in a certain way. And he talks about also a future where a building is basically a service. It's basically you are not buying a building or buying a house, but you are actually kind of like purchasing a service from different manufacturers that maintain these materials that they know by their material passports and by a digital twin. So to me, it's like it's an amazing.
That's kind of mind-blowing to think of building as a service. The architects are thinking of building as an experience. There's so many different layers of complexity. And to get back to your point a second ago about this kind of material passport, like the rigor that would take to actually assign and track those things over time. And I mean, nowadays, coming from the commercial architecture world, like you can't even get an owner to wash something on their building, right? Like, but actually, if something was decommissioned, to track that when, where, how kind of information and tie that back to the blockchain in this instance, that would all be, I mean, it's a heavy lift, I think, for a lot of people to think about, but I do see the grand vision there and the usefulness of it at the same time.
Yeah, absolutely. And he's building experiments and systems that do exactly that. I mean, he's not shying away from it. So he's taking Topologic and taking, he's interested in also prefabrication. So you can imagine that the building already is made out of prefabricated components that are being brought together. And if you put the information in them, those dictionaries into them, and from the get-go, and they travel along with the design process. So one thing we have in Topologic is that the dictionaries that we put in objects, not only do they just simply stay there static, they're not static. They can affect geometric operations like Boolean operations, but they are also affected by the Boolean operations, meaning that when I combine two objects, that event is encoded in the result. And you know that this new space that kind of emerged came as a result of a design operation that happened on its kind of parents.
And it's live information, right? Like it's a live conversation that's always happening, and it's like this is just steps on a timeline. It's not dead. It's not a dead document at any point. So that's very interesting.
Exactly. And it's configurable, and you can we call it kind of like DNA in the sense that you can really trace where that object, where it came from. But also because of that information, it can we call it resist. Like it can resist operations, geometric operations. Like, so for example, if you're trying to take a building and slice it into floors, but you happen to have a central atrium in the middle of that building that you do not want to slice into floors, you don't have to worry about it. Like, you don't have to take it out, put it on the side, slice the building, put it back in. No, you just simply put a dictionary in that says, this is an atrium that does not get sliced. And you go ahead and slice, and it will not be sliced because it has that rule embedded in it.
Oh, man. This is so interesting. So you gave us a little bit of a glimpse of where this might go in the future with blockchain and tracking these items over everything having its own timeline and all that being linked to the blockchain so that, it's immutable. You can actually see what happened, who decided, when they decided, all those things. What else are you guys excited about with the future of where this could go? Is there anything else?
I mean, we've mentioned several things, and they are all threads that we have, pulled on and kind of prepared the groundwork for. So obviously, energy analysis was the early one. You can do energy analysis, you can do structural analysis. You can do graph theory type of analysis, like shortest distances, space syntax type things. The conversion to BIM is obviously a big one, because it will, as you said, it will link it and continue the journey of it. The issue of material passports on blockchains is another one. We have now are able to save topologic entities to graph databases with full information. We're using Neo4j, and we believe that has an amazing potential, because once it's inside a graph database like Neo4j, you can do data mining on that, you can do machine learning on that, et cetera, et cetera. So you don't have to worry about doing that stuff in Topologic. You can do it all in a robust commercial graph database.
I'm just smiling because of all of the things you just said. How many of those things were you thinking about when you attended that lecture?
Probably just one. Probably, I mean, I was just excited about energy analysis,
Yeah,
really. I
that's
mean,
so
it was,
interesting.
but we had an intuition that if we kind of like build it correctly, build it the right way, there's a lot of possibilities. We always knew that there's going to be a lot of possibilities to build on top of Topologic. I mean, people ask me, so what is Topologic? Like, what kind of software is it? They ask me, is it a plugin? Like, is it a plugin for Dynamo or is it a plugin for Grasshopper? And the answer is yes, it is. It acts like a plugin, but it's really not your typical piece of software that you use it to accomplish X or Y. It is an API. It is a foundation. It's really meant for people who would like to build a domain-specific piece of software on top of it, or at least a workflow that uses it, that solves a domain-specific problem.
So it's very horizontal in that way, and people can build their different verticals on top of that because that's where their specialty lies, and they might want to configure it in very specific ways to accomplish the goals of their architecture.
100%. That's exactly right. I mean, some of the early discussions, now I'm remembering the discussions I would have with Robert H. And this is something that came up recently because the CEO of TestFit.io, Clifton Harness, made a bit of fun with it, where I called it apertures. So we have an object in Topologic called apertures. And apertures, we use that term specifically. It just, you can think of it as windows and doors, openings, basically. But we actually had a big discussion with Robert about not calling them windows and doors, simply because, as you said, people will say, well, I don't have a window. I don't deal with windows. I deal with openings that I need to put a pipe through. So that's not a window. That's just an opening. So why are you calling it window? And it's kind of like we'll have a mismatch. So we were always looking at terminology and vocabulary that is more general, that people then can take and subclass into a window. So an aperture can become a window, an aperture can become a door, an aperture can be a hole in the wall. That's all it is. But yeah, that's how we thought about Topologic, is that it can be customized, and as you said, vertical kind of applications can be built on top of it.
Yeah, thinking about that architecturally, even with a facade that's curtain wall, is it window? Is it wall? I mean, yes, both, right? It's interesting to think about this idea of the hierarchy of classes, vocabulary that makes sense, so that other things can be included within it. And it's very interesting to kind of think about it that way. Speaking of test fit, speaking of using this as a library of information that can be called from within other applications, give everybody a sense of how they could potentially use this right now.
Sure. Obviously, this now gets into a little bit more kind of a technical area because we assume that you are a software developer trying to use it. If you're not a software developer, if you are just a user architect, you want to use it, then the best way to access it is either from Dynamo or Grasshopper or Blender. And for me, because if you follow me on Twitter and LinkedIn, you know that I am a big advocate and supporter of open source, free and open source software.
Yeah, you guys have been doing a ton of work with Blender recently.
Yes. So Topologic's main impetus now is within Blender and its connection to IFC, hopefully, and BlenderBIM down the line.
And that's fairly recent, right? I mean, that's been something that is only in the last year or two?
Yes. We finally, in the last year and a half, been able to take the Topologic software, which is written in C++, and write a Python binding on top of it. And now you can access it through Python. And Python is great because it doesn't have to be compiled. It's accessible to a lot of researchers that use it. I absolutely love it. It just opened the door to Topologic.
Yeah. And so what unlocked it for you guys with Blender? Because Blender, I know Blender is gaining popularity, obviously, as being open source, but also because of BlenderBIM as far as in the architecture world. So what unlocked Topologic going into Blender as an idea, not like the specifics of Python and how, but how did you get to Blender and why are you so excited about it?
Yeah. if people can see me, you know that I'm of a certain age, and therefore I cut my teeth on 3D Studio Max.
Right.
And 3D Studio Max is a general but powerful 3D modeling and rendering package. So I've always been a big fan of 3D Studio Max. I've taught it to my students for many, many years. I stopped recently. When I looked at Dynamo and when I look at Grasshopper, they're great, they're fine. But I felt that I used to have a much more powerful package with 3D Studio Max. So I was always looking for how Topologic can be hosted by a really powerful geometric engine.
And did you like 3D Studio Max because of like the modifier architecture that you could apply? Okay.
Absolutely. And also I've written a lot of scripts for it. So I was able to, and I was teaching those scripts as well. But it was really powerful in terms of the Boolean operations were really powerful, the rendering obviously, but the parametric modeling and the modifier system, is really still unmatched. I looked at Blender many, many years ago and found it way too complex and quite honestly very ugly as an interface. So I kind of like shelved it. So when we were looking at Blender and looking the fact that we did Python, and I got wind that Blender does have Python, that's kind of like what made me look at it again. And I was looking for something open source. I was in a state of mind where I wanted to move away from paid software. I mean, Dynamo has been great for us because it was kind of the first home of Topologic and we still support it. And Grasshopper came next. But I wanted a end-to-end open source solution. And I couldn't do that with Rhino, which is paid, and with Dynamo, which is, yes, free and open source, but it's linked to Revit, which is paid. So I just wanted for somebody who is perhaps an independent type of person, does not want to pay a lot of money to these big companies, just wants to create an ecosystem that is open source. I wanted that. Also, we had made a promise to the Leverhulme Trust that funded us to be platform agnostic. And Dynamo and Grasshopper do not run on Linux. So we were looking for a universal solution that would run on Linux, on Macs, and on PCs. And now we've reached there. We've been able to do that with Blender.
Yeah, that's interesting to think of why you did that. But I mean, but some of the interesting stuff that comes out of that now, I think it does seem kind of ahead of the curve in that the potential of BlenderBIM, because of its open source, because of its community, gives the ability. I mean, you could see the potential that has within the architectural institutions. I can imagine on the school side, that could be a very big deal. I know that the software companies like to give their software to students, right, to get them hooked, but there's also this totally free forever kind of a choice that they have, which has got to be a big deal. But also, as firms are disillusioned with software vendors and licensing models and costs and all of those things, development cycles, it just seems like Blender's a rocket ship in regards to that kind of thing.
I fully agree with that. I just want to also clarify, because I don't want your audience to think that Topologic can only be accessed from Blender or it's a plugin for Blender. Again, it's not Blender is one interface, and Blender has something really unique called Sverchok, which is like a Grasshopper clone that is quite robust.
It doesn't roll off the tongue like Grasshopper.
Yeah, it's a Russian word. It's some kind of insect, I believe, still some sort of insect, if I remember correctly. But it's really a powerful alternative to Grasshopper, and that's what I've been developing. But all of these things are simply interfaces into Topologic. You can open one of those black command line windows and open up, fire up Python and then say import Topologic and start making Topologic entities by typing in commands. It's that available if you would like to do it, and that's why I'm able to move it now to FreeCAD, because it's a Python module, so it can work under different systems. But here's the important thing about open source and about Python. There is a ton of libraries, Python libraries, that are available, that are also free and open source, including things like machine learning, including blockchain, including getting web pages, including drawing charts. anything you want is available as a free Python library. So you can assemble your own ecosystem exactly the way you want it. With no restriction, nobody tells you what to do, what not to do, when your license expires. It's all available. So you can build your own kind of environment that can do really powerful things. So just recently, and today I told you I was coding all day. I'm putting the final touches on a graph machine learning system in Blender. It's expressed in Blender, but it uses PyTorch and pandas and all of that. And I was able to do all of this and connect it to Topologic, because Topologic does graphs, all for free and all by looking at online tutorials and asking for help in forums and doing that kind of work. And it's just that kind of power that if you are a DIYer type of person, it's unmatched by software companies. And when they do something interesting, obviously they are a software company. They obviously would like to charge money for it. I mean, good for them. That's how they operate. But a lot of the stuff is available if you know where to look.
It's really interesting because, I mean, you're coming from an architecture background, but it sounds like you're a computer scientist. And I think a lot of architects probably aren't willing to bite off what it would take to do the things that you just mentioned right now, but they are already working in some of the other tools that you guys are supporting, right? Which is Revit and Dynamo, Rhino and Grasshopper, Blender potentially. I'm just wondering, you said you're not at the point yet where people can necessarily play with geometry in the ways that we're talking about, but do you see that coming as well, as far as like some kind of a UI that gives you direct access to the library so that people can play, and then that could then become the beginning of architecture?
Yeah, I mean, we don't have any current plans on that. Right now, we're still in the world of visual programming, very much like you would work in Grasshopper. But interactivity and play with a geometry in a 3D view, and then having Topologic behind the scenes kind of operating on it, that's a dream. That is absolutely something we need to do. Right now, the only way we can do this is you can do that in a Blender 3D view, and then go into a side window of Topologic inside SphereChalk and say, okay, give me those geometries, and then operate on them, put them back in the 3D view. It's not a very easy process. Obviously, it's going in and out, but we definitely need resources. We know what is needed, but we need the resources to actually make it happen.
Are there people in the Blender community that are excited about Topologic coming to them and being an available tool to them?
Oh yes, there are a lot of excitement around Topologic. I tweet and it gets retweeted and liked. There is definitely a lot of excitement about it. I would say people are, my sense, I might be wrong, but they're like watching and enjoying the show in a way, because they see these amazing new ideas and new capabilities of Topologic. But I think they need more of an incentive to actually start using it on a real project. Very few people have actually taken it up and said, okay, let's do something real with it. And I keep having occasional, maybe once or twice a month, meetings with people from industry saying, from our big architectural office saying, we would like to use Topologic in this case, and and can you help us kind of deploy it? And I'm happy to do that.
I would think that there would be a not too difficult way to quantify, just thinking about it from like that energy modeling perspective that we started off talking about, quantifying the amount of time that people could save to not have to take their complete Rhino model or complete Revit model and dumb it down to do these types of analyses on. I mean, that is kind of a painstaking process, and I'm sure some people have even automated it to some extent. But at the same time, like, it has to include all of various work from our consultants, and the same process has to happen to their model as well, because that's the complete model that needs to be analyzed, right? A lot of times. So you think about the structure needs to be included, and we need to know what these surfaces are, right? We need to know what they're made out of so that we can assign the R values and all of those things. And to not have to go through that process where you could, again, potentially miss something and it could be incorrect, and then you have to do it again or go back and noodle with it. And if all that information was there the whole time, it doesn't seem too difficult to quantify how much time is saved, because we do it the other way every single time.
Yeah, 100%.
We do it the hard way.
I'll leave you with this last story because that's exactly what you have just described. I'm not going to name the company, but basically what we have done with this company is, you probably can find it if you search me on Twitter, implemented Speckle. So now Topologic can connect to Speckle. And therefore, they are creating their models and instances of these models from Revit. They're getting the rooms out of Revit, but they're also operating on them so that there's actually some serious work there where they are actually Topologic compatible, and I can build a cell complex because sometimes they are separated, but we don't have that problem.
Yeah, if you have two rooms, you have the thickness of the whatever's in between them, and now you have
solved it. It's really amazing. I don't exactly know the details, but they have solved it. And then the model comes through Speckle to me, where I am sitting here in Cardiff, to my Blender stuff. I go through my Blender workflow, do the energy analysis, and through Speckle send them back all that information. So somebody could, I'm an academic, I have a job, I don't need it, but somebody could actually make a business out of this.
I thought you were going to throw this big firm under the bus, but you just highlighted their work.
No, I'm not going to throw them under the bus. They're fantastic. No, they're amazing. And what also this kind of indicates is that these firms, or if you are listening and you are somebody who has a firm or works in a firm, there is no risk in using open source software because the data is always open and available, and you can always change your mind. And you can stay with Revit, and then through Speckle, through these types of technologies, interface with open source software, send them the data, do whatever you need to do there, and come back. And if it's of value to you, keep doing that. And if it stops being of value, all your data is still with you in Revit. And the open source can just simply fade away if you don't like it. I don't think it will ever fade away. I think actually, like what happened with ePro Consult in Germany, more and more, they started with Revit and Dynamo and Topologic and Dynamo, and they did not want to touch Blender. A year and a half later, now they are deploying Blender and Topologic because they don't see any risk. Blender is well established, it's well supported, BlenderBIM is there, Topologic is there. And if they ever find that it's no longer useful, they still have their Revit processes.
Yeah, I think that's a really important point to make because I do think that a lot of people are turned off to open source because what if the developer just disappears? What if it dies? And to your point, you still have your information, just like you do in that Revit 2013 project that's archived on your server that you can't open, right? That's a pain in the butt to open anymore. So it's actually not any different than that. So it's a very important point to say that it's worth pursuing, and you just have to understand it that way, and don't have the fear, that kind of undeserved fear that it's just going to disappear one day and all of your information is going to go with it. Well, Wassim, this has been an amazing conversation. I think it's been really informational, really fun, and really I hope that we're making the ideas of Topologic accessible to a lot of people. And so I just, final question to you is, do you have any ask of the audience? Where can they follow you, find out more about Topologic, download the application? And I'll include everything in the show notes to this episode, but go ahead and tell everybody.
Absolutely. First of all, I want to thank you for hosting me. I think I love doing these types of podcasts because I would like to get that, at least if not the software, at least the ideas behind it shared. So this is really an important service that you provide. In terms of getting in touch with me, info@topologic.app or topologic.app or wassim.jabi@gmail.com. You can get in touch with me. Definitely follow me on Twitter. I'm very active on Twitter. I post almost every day kind of updates. I overshare even, but the handle is Topologic BIM, Topologic BIM. And then I'm also on LinkedIn under my own name, but that's less active. The website is topologic.app, but also the software can be downloaded from GitHub. So if you just search for GitHub Wassim Topologic, three words, you'll find it. It's a one-click install for Blender. It's Topologic's Virtual, it's called. You can just download the zip file and just install it through the preferences in Blender, and there you have it.
Fantastic. I'll include links to all of those destinations in the show notes for this episode, which everybody can find at trxl.co. And Wassim, this has been a fantastic conversation. Thanks again.
Thank you. Thank you very much.
Thank you to Avail for their support of this podcast episode. Visit getavail.com to see their holistic approach to content management today. Thank you to BQE, the makers of BQE Core, for their support of this podcast episode. Visit bqe.com/masterclass to register for the next Designing Your Business Masterclass. This show is part of the Gabled Media Podcast Network. You can see all the shows at gabledmedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for eTroxel. Talk to you soon.